All right, now example 4 is something new. Okay, now if you have a highlighter, I would suggest you to highlight something. If not, that's fine. You could just underline something. If you have a highlighter, I would suggest you to highlight this portion. Okay, because it's not really hard at all. It's just that now we have some conditions. We have some conditions before you pick which function to use. So for the, we call this a piecewise function, piecewise. So we have 3 separate pieces, first, second, and third, okay? And each piece has its own dedicated domain. So for example, if I ask, hey guys, I want to find out g of -3. That means x is -3. So in this case, which piece do we use? The first, second, or third? If x is here, -3, which piece do you use? First, second, or third? First, right? Why is it first? Yeah, it's the x is less than -1, so it's the first piece. So what do? You use the first piece. You'll be like, oh, that's easy. So all we're writing here is that we are telling you, hey, at different region or domain, you have different functions to be applied to. Okay, so in this case, you have the first piece. Like, oh, okay, -2 times -3, which is 6. 6 plus 5 is 11. Hey, what about the next one? G of -1. What do we? Which piece do we use then? In this case, the what? The second one, right? Because right here we have x is greater than or equal to -1. So g of -1 means you have to include -1. So so we use the second piece right here, and that gives you -2 as the answer. All right. And let's do this one here. G of 3 2/3. Okay, we don't usually use mixed numbers, but here we are. What about this one? Which piece do we use? The third one, the step function one, right? So we say, oh yeah, we have a number x that it's greater than 2. So we have this step function of 3 2/3. It's going to give you 3. Okay. How about this? How would you handle this? G of pi. What is G of pi? 3.14, right? So, okay. Well, in this case, which step? Which piece would you use? The step function one, right? The last one, the last piece. So we basically do a step function of pi, which we know is 3.14 something something. And a step function of 3.14 is simply 3. Okay, oops. So can you quickly, using the next minute to finish the rest, okay, analyze which piece to use, and then go ahead and find out the values. Easy? Not scary, right? Piecewise function. For some reason, people got scared. Then they saw piecewise. They're like, what is this? This is huge. All right, so G of 2. G of 2, we use the third piece, the step function piece. So that's going to give you 2 because x is greater than or equal to 2. G of -3/2, which is -1.5. So it's less than -1. So we're going to use the first piece. So -2 times -3/2 plus 5. So that gives you 3 plus 5. That is 8. Okay, make sure you take care of the negatives. Make sure you cancel the 2 before you multiply them. G of 0, we will use the middle piece because it is right in between -1 and 2. So 0 squared minus 3, which is -3. Now, as you can see right here, I hope I'm showing something as a role model, and that is you always need to show your substitution. Even though it is 0, even though it's not going to impact the value at the end, you must show your substitution. It is a habit, okay? It's not about getting points or losing points. It's really about, do you know your habit that will help you down the road, okay? So it's not about me, it's about you, okay? So a step function of 2.7, just 2. Easy? Easy, right? All right, now we have done with the values. Then what about the graphing part? So this one is a very straightforward example. We have 2 linear functions. Now, let me show you how to think through it, okay? So the way you can think about it, one way to think about it is this, okay? 2x plus 3, you know, the intercept is 3, the slope is 2. So you can go ahead and draw the graph and say, yeah, I know how to draw the graph. That's easy, right? And so you have this, but then it also sets something. It sets what? X is less than or equal to 1. So that means after you erase some part of the function, so it is only up until 1. Okay. Now, this is one way you can approach this. Okay, this is how you can think about it. It's really what it is. It just tells you that, hey, we have 2 regions here. So to the left, we graph this. To the right, we graph the second one. Okay, so so if you highlight the region, if you highlight the domain right here, then you know which region would have which graph. Okay, so very straightforward. Now, how would I do it in the most efficient way? Okay, I'm going to show you. The most efficient way would be this. This is x is less than or equal to 1, right? So I'm going to put the 1 in here. So 2 times 1 plus 3 is equal to 5. So I'll be like, okay, so we have at 1, it's equal to 5. So I have a closed circle right here. I know that it has a positive slope of 2, and it has a y-intercept of 3. Okay, y-intercept of 3, that's my graph. I draw my first dot, it is a closed circle, and I draw the slope, done. Okay, it does not involve any kind of erasing. Okay, and then the next one, I'm like, okay, this will be an open circle at x equals to 1. Okay, not a closed circle, but an open circle. And I'm going to substitute in the 1 and say, oh, what is -1 plus 4? That would be 3. So that means I would have a closed circle, oh, no, I mean open circle at 3. Okay, I have an open circle at 3, and it has a slope of what? -1. So, so I'm going to draw a graph with a slope of -1. And this is how we create a piecewise function graph. Okay, again, you have different regions. X is less than or equal to 1. X is greater than 1. Okay, make sure you know when to use the open circle, when to use a closed circle. And this is as easy as it can get. We are just asking you for a linear function. And guess what's going to happen? We are going to get to something more challenging, not just linear function. Okay,